Hello everyone, welcome to today's tutorial on GIS application for soil erosion modeling in using the revised universal soil loss equation. So this is the second part of this GIS application soil erosion modeling under revised universal soil loss equation. Okay, so in this tutorial we'll see about rainfall erosivity R parameter. Okay, first parameter. And as you know that, as we have mentioned in the first tutorial, this erosivity is the ability of erosion agents to cause soil attachment and transport. Okay, so this soil the rainfall erosivity is the ability of the erosion agent, actually in this case the rainfall, to cause soil attachment and transport. Okay, therefore the rainfall erosivity R was calculated accordingly to the equation given by this Hurney in 1985 and derived from spatial regression analysis by Helden in 1987 for the Ethiopian condition. Alright, so this R is or the rainfall erosivity is given by simply this equation, minus 8.12 plus 0.56 times P, and this P is mean annual rainfall of different or the surrounding stations on a watershed. Okay, I hope you have an information how to know or determine the mean annual rainfalls of different stations. As you see here, this is the universal soil loss equation requires the mean annual rainfall of the surrounding stations, okay, in order to determine the rainfall erosivity, and that may make the model very interesting and selected by different researchers. Good. So for this tutorial we have selected around 6 stations. The first one is Bahar Dar, Merawi, Adet, Mashanti, Tisaba and Sakala stations. Under this there are different locations X and Y as well as elevations, and the mean annual rainfall of those stations are actually available here. I have gathered those available informations from 1990 up to that of Tioni, yeah, for around 31 years data. After that I have calculated the mean annual rainfalls of the stations, and here it is. So based on the previous equation, this rainfall erosivity or R factor is calculated and obtained as this one. Okay, simply you can use this equation in order to know the values of this R. Okay, so it is very simple. Okay, therefore the rainfall erosivity, this R, is in order to compute R factor using such formula. For 6 stations where with a mean annual rainfall were selected, and to know the raster image of your watershed based on the rainfall erosivity, should have to perform the spatial analysis under inverse distance weighted method. Now we can generate the erosivity factor. Okay, so it is better to see it in GIS, ArcGIS environment, and it is already the tutorial part or the theoretical part. Let me show you how to how we are approaching to this erosivity parameter. So the first thing here is, those are the stations under the Excel. We have those stations as we have seen before, and those are the mean annual rainfalls of the stations, and the rainfall erosivity is determined by using the previous equation. Yeah, the previous equation is actually, which is minus 8.12 plus that of 0.56 times 0.562 I hope times the precipitation here. Alright, so if you say that, sorry, plus, let me show you here the formula, which is 0.56, yeah. Therefore here you should have to select not the erosivity, rather the rainfall, yeah, this one. So if you say that, we have obtained the similar ones, just like this. So if you have double click here, you may obtain the erosivity or the rainfall erosivity of each stations, okay, in such a way. So this is the way that the rainfall erosivity is obtained under this Excel. After that, you should have your own watershed boundary, and you should have to add into a GIS environment. For our case, here is Andasa watershed, okay, Andasa watershed, and I have imported the previous Excel. Alright, let me close this since I have saved it before, so it is not necessary to save again. So go to this add icon, and let me add the erosivity, okay, the erosivity R CSV file here. Okay, so in order to visualize it on the GIS environment, you should have to say that display XY data, and the X field is actual X, Y field is Y, but on the Z field you should have to say the rainfall erosivity. Alright, so you should have to edit the coordinate system here. Actually this is WGS 984 UTM zone 37° north for the Ethiopian condition. After that you should have to say OK. Now we are observing our stations, and to make it permanent, should have to export the data. Alright, so here I would like to say it maybe for instance I would like may say that mid station. Let me add one here, mid station 1. Okay, so I would like to add the export data on the GIS environment, and I have seen that, yeah. So we have this information on ArcGIS. So sorry. Therefore after we have added those datas, alright, after we have added those datas, it is better to let me visualize this label based on label feature here. I would like to label based on the erosivity parameter. Go to this property and go to this label here. After that I would like to label based on the rainfall erosivity parameter. Okay, so on this area you should have to select this rainfall E is rainfall erosivity, apply, then OK. So I have those rainfall erosivities on Bahar Dar around 807.86 and the like. Okay, so after you have done this, go to this arc toolbox. Okay, because you are an interest to do the inverse distance. Okay, so the spatial, let's go to this spatial analysis, and there is a thing under hydrology, actually interpolation. Okay, go to this interpolation, then IDW, should have to do IDW. Okay, so that is the inverse distance weighted technique. That is the interpolation technique. Okay, I would like to make this point data into surface. So our input data is mid station 1 we have exported, under Z value field should have to provide rainfall A. Okay, and under our output raster is I can say that erosivity. Okay, rainfall erosivity, that means let me say that R factor simply, or a capital R, say 2. Okay, rainfall erosivity 2. And we can adjust the output size. It is optional actually, so you should have to leave it. And make sure that under environment, when you are working with IDW, you should have to adjust the process extent with that of the mate station. Okay, similar with the mate stations. So here the mate station 1 should have to take care of it. After that, should have to say okay. Now we have the interpolated map here. One thing we have left here is you should have to select or mask your data. You should have to similarly go to this spatial analysis, then extraction, extract by mask. And I would like to extract from our erosivity. Okay, and the input raster feature here is by underside watershed. Okay, by underside watershed. And the final here is the final erosivity is rainfall erosivity here, rainfall erosivity. Okay, so say okay. If it is longer, so you can reduce, yeah, RF. Let me say RF, rainfall erosivity, and say okay. So finally, if you uncheck the previous available maps, just like this, and as well as the main stations, so we have this rainfall erosivity map. Okay, so it is very simple, and we can observe that previously before we are masking, the rainfall erosivity is from 699 up to 1074, but now after masking we have from 732 up to 817. So we can obtain the rainfall erosivity of a watershed in such a way, and I hope it is very simple. You should have to try on your own. And if you have any questions regarding this rainfall erosivity parameter estimation, you can put under the comment section. It is all about today, and don't forget to share to your friends as well. Thank you. Have a nice time.